This is the Rescorla Wagner simulator. Here's your equation on top. So this is the acquisition of excitatory associative strength for stimulus x. And I've arbitrarily set stimulus x as having a salience of 0.8, and I've put the US as having a beta, or salience, of 0.9. Remember that when the US is present, lambda is equal to 1, and when it's not present, lambda is equal to 0. Now, in order to be able to actually simulate incremental learning and not have just learning in one trial, since that's not very realistic, I've added what's called a dampening parameter here, and I've just arbitrarily set that at 0.5. You can play around with this. If you set this as being higher, that means you're going to slow down learning. If you set this as being lower, you're going to, or sorry, if you set this as being lower, you're going to slow down learning. Higher, you're going to speed up learning. But play around with it. It's not really important. It's simply just to slow down the rate of learning so we can actually simulate increases and decreases across trials. So here what I'm trying to show you is that on the first trial, you have 0 associative strength. You're completely neutral. And after the first CS-US pairing, that's equal to alpha times beta times 1 minus the previous associative strength, which is equal to 0, times our dampening factor. And here is the change in the associative strength that we see on that trial. So this is how much learning occurred on that trial. So on trial 2, here's the amount of learning that we start off with. So this is equal to V. Now on trial 2, we pair the CS with the US, and here's how much learning occurs. So you can see that on each subsequent trial, the amount of learning that occurs gets smaller and smaller, and that's reflecting the fact that the predictive error is getting smaller and smaller, but the overall sum of the associative strength gets larger, and that starts to reach what we call asymptote, which is the maximum amount of learning that is possible. At extinction, we stop presenting the US, so now lambda goes to 0. So lambda is equal to 0, which means that we have a negative change in the associative strength. So now this is the acquisition of inhibitory associative strength or negative associative strength. And we could see that responding or associative strength goes down, which also corresponds to responding going down. So you can play around with this simulator. You can see what happens if you change alpha. So instead of 0.8, what happens if we go to 0.2? Well, we can see that that reduces the rate of learning because the CS is no longer quite as salient, so it's a much slower rate of learning. What happens if we change beta? Well, if we go to 0.3, again, this slows learning because the US is not as salient. It can't support as much learning, so we have a lot less learning for every given trial. So play around with this. You can see how changing the parameters of the CS and the US, or you could even see how changing the dampening factor would influence the acquisition of excitatory and inhibitory associative strength, which of course corresponds to changes in our behavior.